Good afternoon. This is Kavipriya, Assistant Professor, EC Department. So I am going to discuss about the Schering and Wien bridge, which is an AC bridge. In last video, we have discussed about the DC bridge, introduction to bridges, DC bridge, AC bridge, and Wheatstone bridge, which is a type of a DC bridge. In today's video, we are going to discuss about the Schering and Wien bridge, which is a type of a AC bridge. So Schering bridge is a bridge circuit. It is used for measuring a unknown capacitance, and it is also used for measuring the dissipation factor of the capacitor. So it is a AC bridge. So AC supply will be given to the Schering bridge. So here we will be having a 4 branches. In one branch we will be having a resistance and capacitance which are connected in series, and the opposite branch will be having this resistance and capacitance which are connected in parallel. In the remaining 2 branch will be having a resistance and the capacitor. One branch will be having a resistor, another will be having a capacitor. To any 2 junction points, a supply will be given, and other 2 junction point, a galvanometer is used connected to find it indicates the value of the current that flows in the bridge circuit. So when the bridges being get balanced, when Z1, Z4 is equal to Z2, Z3, the galvanometer shows a null deflection. The components are C1 is an unknown capacitor and R1 is a series resistance which is connected in series with the capacitor C1, and R3 is a resistor, non-inductive resistor, R4 is a variable non-inductive resistor, and C2 is a standard capacitor, is an air capacitor and is a loss free. C4 is a variable capacitor which is connected in parallel with the resistor R4. We all know the bridge condition is that the impedance of the opposite arm should be equal. So Z1, Z4 is equal to Z2, Z3. And for Z1, this resistance R1 and capacitance C1 is connected in parallel. So we have to write the impedance form for R1 and C1. And Z4, this R4 and C4 are connected in parallel. So we have to write the impedance form for the components connected in parallel. And Z2 is in case of Z2 we have a capacitor C2, and we have to write the impedance form for the capacitance. And for Z3 resistance is connected, R3 is connected, so the impedance of R3 is R3. And on simplifying we will be getting the after simplifying we will be getting an equation which consists of real and imaginary part. We can replace 1 by j as minus j, and we have to simplify the equation in such a way that we have to equate the real terms and we have to equate the imaginary terms separately. So while equating the real terms, we will be getting R1, R4 will be equal to C4, R4, R3 divided by C2. From this we can find the unknown resistance R1 is equal to R3 C4 by C2. And while equating the imaginary terms, we will be getting the value of unknown capacitance C1. C1 is R4 C2 divided by R3. From the value of this C1 and R1, we can determine the value of the dissipation factor. And the dissipation factor is nothing is a power that is being get dissipated by the capacitor. So the equation for dissipated factor is nothing but omega C4 R4. Omega is equal to 2 pi f. And next is the advantages of this Schering bridge. The balance equations are there free from frequency. The arrangement is less costly as compared to other bridges. Drawback is that it is difficulty in obtaining the balance as R3 appears in both the R1 and C1 expressions. Application is that some of the applications which uses Schering bridges are: first one, it is used by the generator; second one, it is used by power engines; and it is used in house industrial networks. Second is a Wien bridge. Wien bridge is also a type of a AC bridge. It is used for measuring the frequency, and also it is used for measuring the unknown capacitance with high accuracy. And under the construction of Wien bridge, we will be having a 4 branches, and the resistance and the capacitance are counted in parallel in one branch and series in one branch, and the remaining 2 branches consist of the resistance R3 and R4. Supply will be connected to any 2 junction point, and the director will be connected to other 3 junction points. So here also it is involved in the, since it is a AC bridge, we'll be finding the value of the impedances. We have Z1, Z2, Z3 and Z4 are the four impedance, which are the impedance of the corresponding branches AB, AD, BC and CD. Z1 is nothing but R1 by 1 plus j omega C1 R1. Z2 is R2 minus 1 by j omega C2. Z3 is equal to R3 and Z4 is equal to R4. We all know what is the bridge condition, right? So the impedance of the opposite arm should be equal. So Z1, Z4 should be equal to Z2, Z3, and we have to apply the value of Z1, Z2, Z3 and Z4 in the equation, and we have to simplify the equation. So after simplifying, we have to separate the real and imaginary parts separately. So while equating the real terms, we'll be getting R4 by R3 will be equal to C1 by C2 plus R2 by R1. While equating the imaginary part, we'll be getting the 1 by j omega C2 R1 plus j omega C2 R2 is equal to 0. So while equating the imaginary part, 1 by j will be taken as minus j. While equating the imaginary part, we won't be considering j terms. Excluding a j terms, we'll be having minus omega C2 R1 plus omega C2 R2 is equal to 0. From this, omega value is nothing but 1 by square root of R1 R2 C1 C2. We all know omega is equal to 2 pi f. 2 pi f is equal to 1 by square root of R1 R2 C1 C2. So this we are considering that R1 is equal to R2 is equal to R and C1 is equal to C2 is equal to C. So while substituting this condition, we'll be having F is equal to 1 by 2 pi RC Hertz. So the unknown frequency is obtained and also the unknown capacitance is being obtained. Advantages is that it is very simple circuitry and it is very cost effective and it can make the quantitative measurements, which means that it has a capability to measure frequency and capacitance of a circuit with high accuracy. Drawback is that it has a limited frequency generation. In the output produced there's a chance for the high distortion, and it is not purely sinusoidal AC input voltage is given. It consists of the harmonics. Application is that it is used for measuring the frequency, it is used for measuring the capacitance of the circuit, it is used for analyzing a distortion due to harmonic disturbance. It is also find the application as a high frequency oscillator. It is used for estimating the frequency values in audio and radio oscillator. So that's all about the construction, working principle, advantages and drawbacks of the Schering and Wien bridge. Thank you.